It's Ag2 gallium.
Do you see any change in the properties of your wire depending upon what was the thickness of the silver that you coated, or changing that balance?
Yes, sure. So more silver you put, basically, the longer needle you might get. The most important thing about those needles is that almost all the parameters can be controlled. Length, diameter, direction also. So length can be controlled again by the thickness of silver, but if you put too much, it's not that good. They will just break at the base. So optimum size is like, optimum thickness about 30-50 nanometers total. Okay, and thickness can be controlled by the temperature. Higher temperature, well, it's again related to my talk. Structure goes closer to thermodynamically favorable shape. It becomes thicker, shorter. Okay, this can be achieved by variations in temperature. Direction, well, this is obvious. It depends how you dip it into gallium droplet, and it will define the direction of this group, crystal group.
I noticed that in your graphene measurements, you have two probes typically.
Right.
Don't you have a lot of problems with contact resistance?
A lot. We do.
So all of those measurements
we have a lot. Well, the good thing about that, as I told you before, why we do it this way, obviously it's not good, maybe not the best way to do it. The best way is to make a device. But since it's semi-metal, for the most part you have some kind of metal-metal contact. It's not totally Schottky contact. So at least we can say that primary contribution in these measurements is from the properties of graphene, not from the properties of contacts between graphene and metal. Because for the most part, we have contacts between two metals. But I agree with you that four-terminal measurements are always better. The problem with lithography on any kind of carbon structure, because normally people try to do devices, make devices lithographically. Lithography involves polymers in fabrication process. So no matter what you do, you need to coat your material with polymer. And polymer contains lots of carbon compounds. So recently some chemists already proved that if you make a device using polymers from carbon nanotube, you cannot remove all the polymer, and you don't really know what you measure. So you basically measure conductivity of polymer for the most part. So this is unfortunate, but most of the papers about carbon nanotubes, lithography-based carbon nanotubes devices, they are wrong simply because people don't know what they measure. And lithography might be even worse example of a device based on graphene. So far that's all we have. But since we have 4-probe station, we're making attempts to assemble them for 4-probe measurement, but it's not that simple. We'll see.
Well, you've already shown difficulty by bringing your probes closer. You saw that the results are very different.
Well, at least I consulted with theorists on that. Conductivity obviously depends on length. And they got similar results for carbon nanotubes, single-wall carbon nanotubes. But I'm trying to catch one professor who's supposed to help me on that, and she runs away every time.
As a theorist, I admired your photographs
Thank you.
of your setups. Is that a confocal microscope?
No, this is a standard SEM for the most part.
Oh, really?
Yes.
Even those dimensional views of...
Yeah.
Oh.
Everything is SEM. Well, besides only pictures of nanoparticles, this is TEM. Only pictures of nanoparticles. But nanotechnology is all about pictures these days. You know, very nice pictures. That's it. That's all. That's all. This is the most important part of your research, to get a nice picture, so people say, "Wow, it's so cool."
You had mentioned the investigation of the least step of your nano line. And normally for soft materials, biological materials, excitable cells, which something like your nanowire would be very useful for neurons, for molecular collection. At the moment, they use liquid-filled micropipettes to measure conductivity or changes in charge density in the organic collections, these cells. Have you thought of moving beyond yeast to moving to neurons or other excitable cells?
I'm going to tell you what is the major problem right now. You see this nice picture how needle goes into the cell. It's a great amount of work to put another one close to it. I mean, although it looks really cool, I mean, even now I'm not sure that it's possible. It's in the project. We keep trying, okay, to put another one. But first step is to do electrochemistry. If we can do electrochemistry, then it will be another step. We have pipette pullers in the department, so we definitely work on pipettes also. Everything less pipettes.
Yes.
So we're working on this too.
Other questions? Let's thank our speakers. I would remind the faculty that we have a discussion with Dr. Dobrokhotov immediately in 2 minutes. Thank you.
Well, this is super expensive. Yeah, Supra 600K. So they're really good. One left. Yes, basically one left.
Yeah, I see your. Thank you.